Hi guys, welcome back to Chem Cheats, and today we're looking through the Edexcel IGCSE Jan 2020 Paper 1C. Question 1 begins by asking you about noble gases. These are the elements in group 0 at the far right of the periodic table. The only element in the box that's in this group is argon, so that's the answer to 1A part 1. The gas that makes up about 78% of the atmosphere is nitrogen, and the greenhouse gas is going to be carbon dioxide. Calcium carbonate has the formula CaCO3, so when you decompose it, the gas given off is again carbon dioxide. Sulfur is the element S, so for the chemical equation you write S plus oxygen, which is O2, it's diatomic, and that will go on to form sulfur dioxide. The environmental problem that this causes is sulfur dioxide contributes to acid rain when it reacts with water and oxygen to form sulfuric acid. Everything on page 1, I'm afraid, is rote learning. There's not that much application involved, and so these are just facts which you need to know for your IGCSE exam. For question 2, you are shown a dot and cross diagram from an unknown element. You need to label Z, which is in the centre of the atom and therefore the nucleus. The number of protons, as this is an atom not an ion, is going to be equal to the number of electrons. So you can count the electrons, 2, 4, 6, 8, 10 and 12 in total, so the answer to this question is 12. The group that contains this element, well, that's going to be the equivalent of the number of outer shell electrons, which in this case is 2. The period that contains this element is equivalent to the number of electron shells, which in this case is 3. The charge on the ion formed from this atom, this is when it goes to form a full outer shell. Well, you've got two options. It's either going to gain 6 electrons to have a -6 charge, or far easier for the atom to achieve, lose the 2 outer shell electrons to form a 2+ charge. Part B is asking you to calculate the relative atomic mass of this element. That means you are calculating the average mass of each isotope of this element. In order to do this, you multiply the percentage abundance by the corresponding mass number and you add these amounts together. As you can see from this calculation, that leaves me with 79.2 times 24 added to 10, which is my abundance of the mass number 25, and I add that again to 10.8 times 26. I then divide that by the total abundance, which in this case, as it's a percentage, is going to be 100. That then leaves me with a final answer for the relative atomic mass of 4.316. I then look at the information I'm given in the question, which is all to 3 significant figures, which means my final answer is actually 24.3. Question 3, and I'm looking at 2 samples of iron. One has been coated in zinc, and it asks me what the process is called when you coat iron with zinc, and the answer to that is galvanizing. The 2 samples are then left outside, and a brown solid containing hydrated iron 3 oxide forms on sample A. The common name for this brown solid is of course rust. You are then asked for the names of the 2 substances which react with iron to form iron 3 oxide or rust. The answer to this is water and of course oxygen. Again, all the answers on this page are rote learning and are just facts which you need to learn ahead of the exam. Part C shows aluminium powder reacting with iron 3 oxide powder. You have seen this reaction before, but you will know it as the thermite reaction. When the magnesium fuse is lit, a very exothermic reaction occurs, and you are asked for the meaning of the term exothermic. That, of course, is that thermal energy is given off. The next question is quite difficult to hit the mark scheme points, as it asks you to explain how this equation shows the relative reactivities of aluminium and iron. As aluminium displaces the iron in iron 3 oxide, this tells you that aluminium is more reactive. You are then asked to explain why the reaction between aluminium and iron 3 oxide is a redox reaction. The reason for this is aluminium is itself oxidized and the iron 3 oxide, not the iron, is reduced. It's important that you put iron 3 oxide here. Therefore, aluminium has gained oxygen, as shown by the equation, and iron 3 oxide, again not iron, but iron 3 oxide, has lost oxygen. Question 4 gives you a table of different ions and asks you to come up with the chemical formulae. If you write out the individual ions, like NH4 1+ and S2-, you can use the drop and cross method, where you drop the numbers down and cross them over to give you the chemical formulae. This gives us NH4 in brackets 2 and S1. As there is only one S, I do not need to write the 1. I can repeat this for Mg2+ and and NO3 1-. If I drop and cross the numbers, I end up with Mg, NO3 in brackets, 2. Repeating this for aluminium 3+ and carbonate 2-, this is the most complicated of this kind of example that you will get. I end up swapping the Al3+ and the CO3 2- to get Al2 CO3 all in brackets 3. Remember, the brackets are there because the 3 applies to the carbonate as a whole, not just the oxygen at the end. The name of the compound with the formula NH4NO3 is of course ammonium nitrate, and the meaning of the term ionic bond is the strong electrostatic attraction between oppositely charged ions. Part 2 shows you a dot and cross diagram of a sodium atom and an oxygen atom and asks you to draw diagrams to show the arrangement of the electrons in ions of sodium oxide. In order to form the ion, the sodium atom has to lose its one outer shell electron here. I draw this by putting Na in place of my nucleus so I know what ion I'm drawing. My first shell will have 2 electrons in it, and then my outermost shell now is the second shell, which has 8 electrons completing that shell. Of course, this is an ion and it's charged, so I must remember my square brackets and my 1+ charge. The second sodium ion is exactly the same. Similarly, I draw my oxide ion with an O where the nucleus should be. My first shell has 2 electrons in, and my second shell will now have 8 electrons in. I actually just copy out the oxygen atom dot and cross diagram that I have been given in the question, and then add 2 crosses to indicate the 2 electrons that have been given to the oxide ion from the 2 sodium atoms. I remember my square brackets and my 2- charge for the 2 electrons I have gained. Question 5 is a question on organic chemistry, and the first question asks for a letter of a compound that is not a hydrocarbon, so I'm looking for any atom which isn't hydrogen or carbon. As you can see, that's the bromine, which is in compound S. Part 2 asks me for the letters of the 2 compounds that have the same empirical formula. I'm going to write the empirical formula of each compound in its box. P is CH4, Q has the molecular formula C2H6, I can divide both of those by 2 to get CH3. R is of course C3H8, S is CH3Br, has the molecular formula C2H4, again I divide by 2 to get CH2, and U has the molecular formula C3H6, which again is CH2 when divided by 2. Therefore the answer is T and U. The letter of the compound that's used to manufacture polypropene will of course be propene, which in this case is C3H6, which is U. Part B is asking for a test to distinguish between compounds Q and T. If I look at compounds Q and T, they are ethane and ethene. So the question is asking for my test to distinguish between an alkane and an alkene. I'm afraid chemical tests are more rote learning from the qualitative analysis topic. In this case, I add bromine water to both compounds. There will be no visible change with the alkane, which it will not react with unless in the presence of a lot of UV light, but with compound T it will go from orange to colourless. The next question is more rote learning, as you're asked for 2 characteristics of a homologous series. There are in fact 5 characteristics of a homologous series, and I'm going to write all of them for you here. The first is similar chemical properties. The second is a trend in physical properties. Please note that these are not the same. One is similar in terms of chemical properties, the other is a trend in physical properties. Do not mix these up. The third is that they all will have the same general formula. The fourth is they will all have the same functional group. And the final point is that they will differ from each other by CH2. Part D asks me to name alkene V. It's 4 carbon atoms long, which means I have the prefix bute. The alkene is between carbons 1 and 2, which means it's bute1, and it's an alkene, so my suffix is ene. The displayed formula of another alkene that is an isomer of alkene V must also be an alkene, it must also be C4H8, and therefore my double bond has to move from between carbons 1 and 2 to between carbons 2 and 3. Remember, for a displayed formula I have to draw every single bond. That includes all of the carbon-hydrogen bonds. Part E is an empirical formula calculation. I need the periodic table to do this question. First of all, I would write out each atom that is present in my compound: carbon, hydrogen and fluorine. I am using percentages, so in order to do this question I will assume I have 100 grams. That will mean 36.36 grams are carbon, 6.06 grams is hydrogen and 57.58 grams is down to fluorine. I then divide all of these by their atomic mass number. This gives me an answer for carbon of 3.03, hydrogen 6.06 and fluorine also 3.03. Now I want this in a whole number ratio, the lowest possible. That's what an empirical formula is. So I divide everything by 3.03, as this is the smallest of the three numbers available. Therefore my carbon comes out as 1, my hydrogen as 2 and my fluorine as 1. You are subsequently asked to calculate the molecular formula of the compound which has an MR of 66. The MR of CH2F, which we calculate using the relative atomic mass of each element in the periodic table, is 33. This compound has an MR of 66, so 66 divided by 33 equals 2, which means everything must double to give me C2H4F2 as my molecular formula for this compound. The next question is experimental and whether or not you can read the burette. Each big division is worth 1 centimetre cubed, so that makes that 17. Each small one is worth 0.2, so that makes it 17.7 as it's in between two small divisions. There is 22, and as each small division is 0.2, I get 22.4. To work out the change, I find the difference, and that's 4.7 centimetres cubed. Continuing on from the experimental theme, I'm then asked why a polystyrene cup is better than a glass beaker in this investigation. It is 2 marks. One is because the polystyrene cup will be a better insulator. Why is that important? Well, that ensures that there is less heat loss to the surroundings. 3 factors that the student should keep constant in this investigation, better known as control variables, are the mass of the metal, the concentration of the acid, and the volume of the acid, as these are all things which can affect the temperature change of this reaction. There are 2 other factors which will get you credit: the rate of the stirring of the reaction mixture and also the room or the external temperature of the reaction. Please note that when you say mass of metal to say mass, not amount. And then we are given a table of the students' results. You're asked why there's no temperature change for copper, and that's because there will be no reaction due to copper not being as reactive as hydrogen. It asks you to predict the temperature change for iron. You're allowed a range for this answer, and any value between 1.5 and 5 degrees Celsius will receive credit. Then you need to deduce the order of the reactivity of the 5 metals. The greatest temperature change will be the most reactive, so that will start with magnesium, then be zinc, followed by iron, tin, and finally copper. Be careful on multiple choice questions as they are designed to be time consuming and only worth 1 mark per question. This question is about trends in Group 7. The first trend is one of boiling points, asking which element is a liquid at room temperature. That is of course going to be bromine. The next is a question about colour, and elements in Group 7 get darker as you go down the group. Therefore the palest is chlorine. Finally, it's about Group 7 reactivity. As reactivity decreases down the group, the least reactive element is the one at the bottom of Group 7, astatine. Part B looks at comparative reactivity of Group 7 elements. It asks you to complete the table. If you add chlorine solution to sodium iodide, chlorine will displace the iodine and the solution will turn brown. In the reverse reaction, iodine is not as reactive as chlorine, so there will be no visible change as no reaction will occur. Why the teacher does not add bromine solution to sodium bromide solution, it is important you hit the mark scheme here and state something along the lines of bromine will not displace itself. The chemical equation for this reaction is Br2 because bromine is diatomic. Remember, your diatomic elements can be remembered by Hunkelbrith. Hydrogen, oxygen, nitrogen, chlorine, bromine, iodine and fluorine. The Br2 reacts with sodium iodide, which is NaI, and that forms iodine, which is I2, also diatomic, and sodium bromide, NaBr. In order to balance this equation, I need 2 sodium iodides and 2 sodium bromides. Part C is to test your qualitative analysis. You're looking for a test to distinguish between the cations, copper 2 and iron 2, and a test to distinguish between the anions, the chloride and the bromide. To distinguish between copper 2 and iron 2, you add sodium hydroxide. With copper 2, you'll get a lovely blue precipitate formed. But with iron 2, you'll actually get a green precipitate forming instead. The test for halide ions involves using nitric acid and silver nitrate. The reason you add nitric acid is to remove any carbonate impurities that might be present in your compound. If chloride ions are present, then you get a white precipitate forming. If bromide ions are present, then you get a cream precipitate forming. Hopefully it's easy to see that the test and the positive result for both cations are worth 3 marks, and the test and the positive result for both anions are also worth 3 marks. Question 8 is factual recall. The name of the change of state from solid to gas is of course sublimation. Describing the test for carbon dioxide gas, the test itself is to bubble the gas through lime water, and the positive result is it will turn lime water cloudy. In other words, form a white precipitate. Whenever you meet a question asking you to explain the boiling point or melting point of a substance, you need to think about structure and bonding. The question tells you that carbon dioxide is a simple molecular covalent substance. Therefore, its melting point and boiling point are determined by weak intermolecular forces. These require very little energy in order to overcome them, hence it will have a low boiling point. Question C is a more challenging structure and bonding question. In diamond, each carbon atom forms 4 bonds, whereas in graphite, each carbon atom forms only 3 bonds. They are both giant covalent substances. In diamond, each carbon atom will form 4 bonds. In diamond, you get a giant tetrahedral lattice. There are strong covalent bonds between the atoms. For these reasons, diamond is very hard. In contrast, the carbon atoms in graphite form only 3 covalent bonds each. These atoms are arranged in layers rather than the tetrahedral lattice of diamond. They have weak intermolecular forces between these layers. Because of this, the layers are able to slide over each other with relative ease. All of this means graphite is soft. Question 9 and more experimental questions. Why should the student measure the mass of the spirit burner immediately after heating the water? The answer is to minimise evaporation of the fuel. When the fuel is burned, a black solid forms. What is the black solid? It's of course carbon or soot. And why will the black solid form? Because there is an insufficient supply of oxygen. This means incomplete combustion occurs. You need both of these points to get both marks in this question. C part I is an energetics question requiring the formula Q equals mc delta T. M is the mass of your water. As we've used 100 centimeters cubed of water, we have 100 grams of water. C is 4.2 as given in the question, and the temperature change is 30 degrees. That gives us an answer of 12,600 joules or 12.6 kilojoules, which is of course approximately the 13 kilojoules given in the question. To work out delta H, I must first work out my moles of methanol. I do this using mass divided by the MR, or in this case 0.96 divided by 32. This gives me an answer of 0.03 moles. To work out delta H, I then need to do negative Q over N, so I do minus 12.6 divided by 0.03. This gives me an answer of minus 420 kilojoules per mole. In part I of the next question, you must plot the points correctly and draw a line of best fit. You then have to show on your graph how you get an answer for the value for 6 carbon atoms. Extrapolate your graph and you'll get an answer approximately at minus 4,000 kilojoules per mole. Stating the relationship between delta H and the number of carbon atoms per molecule is tricky because as the number of carbon atoms increases, the magnitude of delta H increases. You must be specific here as the value actually becomes more negative. Question 10 and the first part of the question is to balance a chemical equation. If you struggle with balancing chemical equations, then remember to check out our video on how to balance chemical equations. If I balance my hydrogens first, followed by my nitrogens, I'm left with 5/2 oxygens. You are allowed to put this, but it's a bit unclear. So double everything to get 4 ammonia, 5 oxygens, 4 nitrogen monoxides, and 6 waters. This symbol is of course the reversible reaction symbol, not to be confused with an equilibria symbol, although this is the topic where you see this symbol the most. The purpose of the platinum catalyst is to increase the rate of reaction. Although it does this by lowering the activation energy, do not write this as that is not what the question is asking. The chemical equation between nitrogen monoxide and oxygen is NO plus O2 forms NO2. However, I do need to balance this equation, and I do this by having 2 nitrogen monoxides and 2 nitrogen dioxides. The reacting mass calculation, and I will copy out the equation in order to give me a framework to answer this question correctly. Once I've written out my equation, I will write down all the information in the question that I'm given, in this case the 11.5 tons of nitrogen dioxide, which I will write out in grams as 11.5 times 10 to the 6. In order to calculate moles, I'm going to need to calculate first the MR of nitrogen dioxide. I use a periodic table for this and it comes out at 46. Personally, I would then highlight what I'm looking for, which in this case is the nitric acid. As I've got a balanced equation, water and nitrogen monoxide are not relevant to my calculation, so I can even afford to cross those out. I then calculate the moles of nitrogen dioxide. I do this by using moles is equal to mass over MR, which in this case is 11.5 times 10 to the 6 divided by 46, which gives me an answer of 250,000. I have a 3:2 ratio between my nitrogen dioxide and my nitric acid. Therefore, my 250,000 is divided by 3 and times by 2 to give me 166,666.67. Remember not to round this value. The MR for nitric acid is 63, and I rearrange my equation to mass is equal to moles times MR. If I do this calculation of 63 times 166,666.67, I get an answer of 10.5 times 10 to the 6 grams, which comes out at 10.5 tons. Part C asks what use can be made of the nitrogen monoxide gas formed in stage 3. If I look at my experiment, I can see that it can be reused in stage 2, as shown here in a screenshot of the previous page. The final question is a percentage yield of copper 2 nitrate. In order to do this, there are 2 methods, but the way I'd recommend is to work out the maximum possible theoretical yield that you could get from the reactants that you are using. Again, I would write out my equation in order to give myself a framework in which to work. I have 0.2 moles of nitric acid reacting with an excess of copper 2 oxide. So I can write this in my table as my moles. I can then work out my moles of copper nitrate in a 2:1 ratio, which comes out at 0.1. If I multiply this by the MR, which I use the periodic table again to calculate, of 187.5, I get a mass of 18.75 grams. Remember, this is my maximum possible amount if I have 100% yield. However, I only managed to achieve 15.3 grams according to the question. By doing 15.3 divided by 18.75, multiplying it by 100 in order to get a percentage, my percentage yield comes out at 81.6%. Thanks again for joining us at ChemCheats for this past paper walkthrough. Good luck in your exam.